Before we get to example 4 on page 473, let's talk about context again in the higher order graphing steps here. The next thing that comes into play is called the rational zeros theorem here under our x-intercept, also called P over Q. And what we do for the rational zeros theorem is we decide which values we want to try to synthetically divide into our polynomial that we're given in order to determine the x-intercepts. Because without the rational zeros theorem, there's an infinite number of numbers that we could try to figure out which ones are x-intercepts. So the rational zeros theorem lets us hone in on only a handful of things that we get to try. All right, we have workspace now. Let's talk about the rational zeros theorem, or sometimes called P over Q. What constitutes P and what constitutes Q? Now here's the fun part. When we look at the equation that we're given, the very first value and the very last value are the two values that we care about. So let's pretend just for a moment that we had something like 12x to the fifth, and then there was a bunch of things in the middle, so we'll put a bunch of dots here to symbolize that, and then it ended with 20. All right, so the P and the Q. A lot of people mistake these. They think that the 12 is the P and the 20 is the Q. Most times they do it because alphabetically P comes before Q. But here's the thing. This is like going to a stadium and watching a sporting event. If you've ever been to a stadium and watching a sporting event live, then you know at some point, typically during the proceedings, you're going to have to use the facilities. You're going to use the men's room or the ladies' room because nature is calling and you need to answer that call. And you go inevitably to the nearest men's room or ladies' room, and then you find that there is a line before you get to go in there to do your business. So we like to call that the Q before you P, as in Q line before you P. So what happens is the 12 is really the Q value and the 20 is really the P value. See, there's a Q, as in 12, from reading it left to right, before you get to P at the 20. All right, so now what we're going to do is we're going to break down the factors of each one of these. All right, so we're going to say, what are the factors of 20? Well, there's 1 and there's 20, and there's a specific way I write this so that when the end is done, we're in from least to greatest order. It works really good this way. So 1 times 20 is 20. 2 times 10 is 20. 3 times nothing. 4 times 5 is 20, and that I know my list is done. Because right after 4 is 5, and it's already on my list. All right, so I'm going to put commas in here just to remind myself that these values are all unique by themselves. And we do the same thing for Q. We say, all right, what are the factors of Q? Well, it's 12, so you have 1 times 12. You have 2 times 6, and you have 3 times 4. And those, again, are all the factors of 12. So I just go down in order. I say, does 1 times something give me 12? Does 2 times something give me 12? Does 3 times something? And once I start repeating, I'm like 4 times 3. Oh, those are already on the list. So I don't have to worry about doing them again. All right, once I have all those factors, then for me to decide the potential zeros, the things that I'm going to try to see if they are zeros of my equation, are every P over every Q. And I don't want to write any repeats. All right, so it goes something like this. 1 divided by 1 is 1. 1 divided by 2 is 1 over 2. 1 divided by 3 is 1 over 3. 1 divided by 4 is 1 over 4. 1 divided by 6 is 1 over 6. And 1 divided by 12 is 1 divided by 12 is 1/12. Again, I'm taking every P value and I'm dividing it by every Q value here in order. All right, so the next one I would do is 2. I'd say 2 over 1. And then I ask myself, is that already on the list of numbers I'm starting here? And if the answer is no, I write it down. I go, all right, 2's there. 2 over 2. Well, that's 1. I already have that. I'm not going to write that down again. 2 over 3, that's 2/3. All right, I don't have that. I'm going to write that one down. 2 over 4 is next, but 2 over 4 is 1/2, and I already have that, so I'm not going to do that one. 2 over 6 is next after that, but that's the same as 1 over 3, so I'm not going to do that one. And 2 over 12 is the same as 1 over 6, so I'm not going to do that one either. All right, so 2 only gave me 2 values here. So I'm going to continue on the same line here just for space reasons. Next is 4. 4 over 1, not on the list, so we'll put 4 here. Next is 4 over 2, but 4 over 2 is the same as 2. That's already on the list. 4 over 3 is next. We don't have that on our list. Next is 4 over 4. That's 1, already on the list. 4 over 6, that's 2/3, and that's already on the list as well. And 4 over 12, that's 1/3. That's already on the list too. So yes, you do have to do some simplifying of fractions as you're writing, because again, the goal is not to have any repeats on the list. All right, next is 5. 5 over 1 is 5, and I don't see that anywhere. Let's keep that going here. 5 over 2, I don't see that anywhere on the list. 5 over 3, again, I don't see that one on the list. 5 over 4, another one don't have. 5 over 6, don't have that one yet either. And 5 over 12. All right, so 5 gave us a lot that we didn't have. But now 10 and 20 are probably going to give us all things that we already have. So let's see here. 10 over 1 is 10. All right, so let's put that one down. Don't have that one. But then 10 over 2 is 5. I already have that on the list. 10 over 3, we don't have that one on the list. 10 over 4, that's the same as 5 over 2. We've already got that one. 10 over 6, that's the same as 5 over 3. We've already got that one. And 10 over 12 is the same as 5 divided by 6. We've already got that one too. So then we get 20. 20 over 1 is 20. So we'd add 20. 20 over 2, well, that's 10. We've already got that one on the list. 20 over 3, well, we don't have that one, so we'll write that one down. 20 over 4, that's 5. 20 over 6, that's going to be 10/3. 20 over 12, that's going to be 5/3, also on our list. So this would be the extent of our list as far as the numbers that we see here. We've taken an infinite number of possibilities down to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 possibilities. And really 40 possibilities, because the last step here is that every one of these numbers could also be plus or minus. So really there's 40 possibilities on this particular equation. Now, none of the ones we do, I think, ever have this high. This is kind of an extreme result of that, but just to show you what the process is. All right, so let's clear this off and let's look at example 4 on page 473. Solve the equation 2x to the 4th plus 10x cubed plus 13x squared minus x minus 6 equals 0. So what they're asking us to do is to find all the values of x that are solutions of this equation. Right? So we're going to have to synthetically divide to do it. But what do we synthetically divide to start with? Right now, we've got an infinite number of possibilities. So for us to do this, we need to first do our p over q. Remember that the q is first. There's a q before you get to p. So our values of p that we're going to look at are 1 and 6 and 2 and 3. And don't worry about the fact that this 6 is negative and this 2 is positive. It doesn't matter in the work that we're going to do. That's what that plus minus values that we talked about at the end of the process, of the PQ process here, really have to do with things. So don't worry about the signs along the way. All right, the q value then is 2, which means 1 and 2 are the only factors. All right, so let's talk about our zeros here. Got plus or minus, and then a bunch of things here. So we're going to take every p divided by every q. Here we go. 1 over 1 is 1. 1 over 2 is 1/2. All right, that ones are done. 2 over 1 isn't on our list. Let's put 2 there. But 2 over 2 is 1. It's already on the list. We're not going to redo that one. 3 over 1, not on the list. 3 over 2, not on the list either. 6 over 1, not on the list. And 6 over 2, though, is 3, already on the list. So here's our list. Our possibilities are 1, 2, 3, 4, 5, 6 numbers times 2, so 12 different possibilities here. And I know some of you love fractions a whole ton, but we're going to try to avoid using those in our synthetic division here. So we're going to concentrate on 1 and then -1 as our first 2. That's always a good first 2 to try here. So we're going to try +1 first to see if that's a solution. And for us to do that, we're going to have to synthetically divide 1 into what we've got. So let's create it. There's 1. Let's do our synthetic division here. We have 2x to the 4th. We have 10x cubed. We've got a 13x squared. We have a -1x. And then finally, we have also a -6. All right. It was 4 power, so we should have 5 numbers in the house. 1, 2, 3, 4, 5 numbers in the house. Looking great. We're ready to start. We draw our line, and we start dividing, right? We bring the 2 down. And we say 2 times 1 is 2. So we put the 2 here. 10 plus 2 is 12. Remember, you're always adding. Unlike regular division where you subtract the terms, in synthetic division, you're always adding. 12 times 1, well, that's 12 again. 13 and 12 makes 25. And at a certain point, you're going to see that this is not going to give us 0. There's no way that 25 times 1, the way this is going to go is going to give us 0. We're going to carry it out because we haven't done very many of these yet for practice. But when you're doing these yourself, and if it comes to an exam when you're doing these, at a certain point you can give up on a number and say, 1 is just not going to work. So let me try -1 next. All right, but we'll carry this one out. So 25 times 1 is 25. -1 and 25 makes 24. 24 times 1 is 24. And -6 and 24 makes +18. Obviously, that's not 0, and this 1 is not a solution then. So we got to do this again. Let's try -1. Again, set up your synthetic division. We know what goes in the house because we've done it once before. Here we go. 2 times -1 is -2. 10 and -2 makes +8. 8 times -1 is -8. 13 plus -8 is +5. This is looking pretty good so far. 5 times -1 is -5. -1 plus -5 makes -6. -6 times -1 is +6. And yes, we just found a 0. We just found one of the solutions to this problem. We know that x, in our grand scheme of solutions here, x equals -1 is one of the answers. How many answers should it have? It should have 4 answers. This is to the 4th power. Now, some may have a multiplicity factor. It may come down to that, but it should have 4 answers one way or another. We just found 1 answer. Great. Well, here's the problem with that 1 answer, though. It didn't get us any closer. Well, it does. I mean, it gets us a little bit closer to finding the rest of them, but we've still got more synthetic division to do because, again, we started out as x to the 4th. As soon as I drew this line here, it became x cubed. So this 2 here represents 2x cubed. There's not much I can do with that. But here's kind of the neat part about doing synthetic division. I can do another number. What I can do is I can redraw my synthetic division with these numbers here in the house. I'm going to ignore the 0. I don't need that. So the only numbers I'm looking at are 2, 8, 5, and -6. And let's try another possibility that we have over here. We had 2. We have 3. We've got 6. We also got the fractions. I would probably avoid using the fractions until the last possible second if I could. So we could try 2. Let's try -2. We had good luck with -1. Let's try -2 and see if that works out. If it doesn't, we'll go back and we'll try 2 instead. Draw our bar. 2 comes down. There's 2. 2 times -2, that's -4. 8 plus -4, that is +4. +4 times -2, that's -8. 5 and -8 makes -3, and I think we picked a good one because -3 times -2 is +6, and -6 and +6 make a 0 again. So we know that -2 is a solution to this one. This is looking good. And here's the best part. After drawing this bar, remember this 2 represented 2x cubed. This 2 now represents 2x squared. And this 4 represents 4x, and this -3 is just that, -3. Remember, it still equals 0 from the beginning, and now we can say we can factor this, or we could use the quadratic formula on it. There's lots of things that we can do to get this to work out for us here. Well, it appears that factoring isn't just going to work on this thing. It's just not factorable. So we'll go to our old friend, the quadratic formula here, and we know that x is equal to -b. So for us, that means -4 plus or minus the square root of 4 squared minus 4 times a, 2, and c, -3, all divided by 2a, 2 times 2, right? Looks like we're going to have -4 plus or minus the square root of 40 all over 4 at this rate. And let's see what our calculator tells us is an answer here for that. Or the 2 answers, I guess, for this. So it looks like our first answer here when we did the plus was roughly 0.581. Let's put that here, 581. And doing the negative gives us -2.581 as well. So there, we found the solutions to it. We've used the decimal with 3 decimal points on it to give us the final 2 solutions. Now, again, in the grand scheme of things, this would be a part of us finding the x-intercepts. And so this work has to be done as part of that. Yes, it can be done separately as a solution, but in the context of graphing, this is going to be done to figure out what the x-intercepts are.